Okay, I'd just like to ask someone, maybe Joanna, if you can alert me if there's a question, because I won't be able to see raised hands while I'm presenting.
Sure.
Okay, so I'm going to start where we left off the last time, and that was at this slide, which talks about when an AI solution is needed. And so I'll just do a very quick recap before we move forward. And then I'll go slowly, and you can, as usual, same ground rules apply. Feel free to interrupt me at any point with any questions. Um, so what we ended with last time was uh, when is an AI solution needed? And the main thing to remember there is that, as you know by now, AI is only exploiting a correlation that it finds between features and labels, right? And because these correlations are almost never perfect, therefore predictions are also never perfect, and there are errors. We will discuss errors a bit later. Hopefully, we'll get to that in the next session on Friday. But when the correlation is almost perfect, you usually don't need AI. And then we talked about a couple of examples with various possible scenarios, um, with both perfect correlations and imperfect and complex correlations. Okay. So I'm going to move ahead, um, and start this session with a discussion very broadly at a high level. What can AI do, right? Again, keeping in mind this correlation discovery aspect, um, what it boils down to is that an AI model typically, again, very high level, very broad, typically does one of two things. And it's good to know before we start working on a problem, it's good to know in a specific problem which one of these two things the AI will end up doing. So the two things are either it automates a task, so automation is one thing it does, or the second is it discovers a pattern that's difficult for us to find as humans. And I'll talk about these two a little bit more. So in automation, what AI does is it takes a task that humans know how to do and simply automates it, meaning it does it faster than humans can. It does it more often than humans can at a higher frequency. It does it as many times as you want it to. And ideally, uh, in an automation task, the AI accuracy will ideally approach human accuracy at doing it. Otherwise, typically the automation, there's a trade-off. You have to worry about trade-offs and so on, right? Um, and the signal. Another way of saying that humans know how to do something is that we know the signal in the features about the outcome. So we know what leads to the outcome. So, for example, if you want to interpret abnormal features in X-ray images, a radiologist knows how to do it, and AI can be trained to do it and automate that task. Right? So this is a task that humans can do. In radiology, of course, it needs to be an expert human, a radiologist who knows how to do it, but an AI can potentially be trained to do it. So what does training mean again? The AI is finding a correlation between some feature in the X-ray and the clinical interpretation, right? And it's exploiting that correlation. Self-driving cars, again, similar. Humans know how to drive cars, and they look at signals in the environment to figure out whether to turn a steering wheel one way or the other, whether to apply the brake, whether to increase speed. If they see an empty road, then that correlates in the mind with increasing speed, so they will increase speed. The AI does something very similar, right? If they see a sudden obstruction or a barrier or a car in front of them, the AI knows to brake based on the signal that it's seeing. This is what humans know how to do. Humans know how to pass the environment with their eyes, and the AI is doing the same thing at near human accuracy. Counting pests on a trap. This is something that we do, um, and very similar. Trained agricultural experts know how to do this. The AI can be trained to do this. We are still not doing it at human accuracy, but there is a potential, given enough data and so on, to be able to do it at near human accuracy. Right. So these tasks are sort of automation tasks. I'll pause here in case people want to. Yes. Sorry, I can't see the hand. So please speak up.
Can I, should I speak the question?
Yes, please, because I'm on full screen. I
Yeah,
can't see
yeah.
the question.
So I was asking about very often automation is considered as a replacement for humans, and like it
Right.
said that accuracy level is almost as much as the humans, and this kind of influenced the user behavior in one of the projects, making them reluctant to use the AI tool. So I just wanted to understand how true is it that the replacement of human role of the AI tool.
Okay. So it's partially true. It's not completely true. And the example I like to give uh, is of calculators, computers versus typewriters and slide rules. Right now, there used to be. I think I'm older than most people in this group probably, and I remember the time when knowing how to type was considered a great skill, and there were armies of typists. And now, you can't find a typist if you want one. You don't need a typist, right? Now, does that mean that the number of jobs out there have gone down and unemployment is increased? No, because new jobs have come up that use, people who can use computers, which didn't exist earlier. So AI will lead to new jobs, people migrating to new jobs. In some cases, AI will reach human accuracy, and then humans will not be required for those tasks anymore. But in many cases, especially in medically relevant decisions, humans will need to be involved. So currently, for example, even if an AI radiology solution is at near human accuracy level, that doesn't dispense the need for a radiologist, because the radiologist will still need to approve the AI. A human has to stand behind that decision and take responsibility because it is a medical decision.
Um, so just that, like one more question about this.
Yeah,
When so when we are talking to the when I am, like, for example, talking to the user,
yeah.
how do I
Sorry,
mitigate?
what's your name? Sorry, I can't see
Neha,
you.
Neha
Neha, yes,
Alpan. Yeah.
yes, Neha. Yeah,
So when I'm talking to the user and trying to mitigate, like, this is like a very common, like, question, and they often would not say it out loud. And you gave this example of, hey, that teleradiologist still needs to make that decision or oversee the process. Okay.
yes.
Um,
And in fact, the idea is that they can see a lot more patients because the AI will help them.
Okay, so would it be correct to say that if the skill is relevant, so if it is teleradiology or something else,
Yeah.
AI is not replacing that skill set. But if the market is changing and then there are going to be new skill sets being that are created, and that, like, it's just the nature of the market and the skill set become redundant because of that, not because of AI, but because the
No,
market
correct, correct.
needs change.
So all technology as it advances will make certain skills redundant. That's just
Okay.
progress, right? But AI in particular, and especially in the use of AI in healthcare, I don't think is going to make the doctor go away at all, and not even a
Okay.
radiologist, because
Okay.
the doctor still has to own the decision and be responsible for it. And so, if you want to think of it in a positive way, which you should, is, the way I would say it is that this is a tool that is used by the doctor to make their work more efficient, just like they use other tools.
Okay. Got it. Thank you.
Right? Any more questions?
I think JK has a question.
Yes,
Um,
JK.
Alpan, I was just curious. Uh, will futuristic AI be competent to automate algorithms as well?
What do you mean by that? What do you
Like,
mean by
like,
automatic? Or like
like,
write code, write its
yeah,
own
yeah,
code?
right code.
Yeah, that's
Like,
already happening. Yeah, that's
oh
already
wow,
happening. There's a lot of research in that area in the area of using AI to write code. So you just tell the AI to write a code that does X,
super.
and it will write code in a language that it's trained to write in. And again, I think currently it's at the point where you do need human in the loop to correct errors in the code, uh, especially errors where it's not doing what it's intended to do, although it's correct code,
Super.
things like that. But that's an active area of research.
That's
And the
fascinating.
and the idea there is that, again, the idea there is very similar to the doctor, where you want to make the programmer's life easier so that they can focus on the more complex tasks.
Correct, correct. So I wanted a reflection on that. As a typical programmer, how do they feel it? I'm only extending the question of Neha. Many friends of mine, doctors, they do feel AI as a perceived threat in their field. Like as fellow programmers, like what's your internal feel about it? It's a very subjective question though.
I don't think I don't think programmers necessarily feel threatened, at least not at this point. Maybe it will happen in the future. But I mean, if they at all feel threatened, they are to blame because they created the AI in the first place.
Thanks, Elton. Maybe you're digressing. Thanks so much for that.
Yeah, yeah. So automation is one task, and I've given you examples. We have a number of projects involving automation. That the test counting thing is one of them. Right, teleradiology is another project. Uh, Pattern discovery is a different aspect of AI, where the AI discovers patterns or discovers correlations that humans have not found or would find very, very difficult to find. Right? So it finds and exploits correlations that humans can't discern. And this is what enables the AI to do tasks that humans can't do. So here, humans do not know a signal in the data that leads to the outcome. And examples are all of these risk prediction type problems, right? If you look at Nikshay as a human, you can't say, what is the risk of a patient dying from TB? Whereas an AI may be able to find a subtle set of correlations that will enable it to predict to modest accuracy the risk of a person dying from TB using various characteristics, right? Various features. So predicting disease risk is something, obviously doctors can do to a certain extent, but AI, because of its ability to process a large number of different data points and then find these correlations between them, may be able to do this better. Diagnosing TB from cough sounds. We've had an internal debate within our organization, right, where there was massive confusion in between because the program team and some external doctors said that you can't tell if a patient has TB from a cough sound. That's just impossible. The textbooks tell you, the textbooks say that it can't be done. Now, when we say that, what it means that a human can't. There is nothing that a human can discern in a cough sound that will tell you if a patient has TB. That does not mean that there is no signal for TB in a cough sound. It's just that humans can't find it, right? And this is exactly the problem we are trying to solve. We're trying to ask: is there a weak signal, enough of a signal in the cough sound that an AI algorithm can detect and find a correlation using training data to predict whether the patient is TB? Right? Is this clear? This difference between automation and pattern discovery? So pattern discovery is not automation. You're not trying to automate a task that humans do. And automation does involve some pattern discovery, but it involves the same kind of pattern discovery that humans are already doing. Right? Now, there are some problems that are, yes.
Alpan, Neha this side. So if a
Yeah.
stakeholder asks what can AI do for a particular field, the answer will be we'll have to find out. Like,
Yes. No, for a particular field is a very generic statement, right? So, for example, you can ask, what can AI do for archaeology? Now, I'm sure there are lots of applications of AI within archaeology, but you really have to drill down to specific problems. Like, can it recognize? So then you can say, well, maybe if given enough data, looking at an archaeological artifact or taking a picture of it, the AI will be able to tell how old it is. But in order to do that, you need enough data of pictures of objects and their ages, and then maybe the AI can do that.
like
It can find that.
So this has come from what AI has already done, like this research being done that AI has been able to do this in archaeology, right?
No,
When
no,
people,
no, not necessarily. Not
okay,
necessarily. I don't know if this has been done. I just thought of this, for example.
okay,
Right?
so um, but in like I'm taking a hypothetical scenario, but
Yeah.
if you are talking to a stakeholder and say, hey, maybe AI can recognize the age of this artifact,
Yeah.
and let's say like you might have taken another area and it might not be, right? So
Correct.
like in terms of like I'm just trying to understand in terms of what is the AI capability and where when you're thinking of new themes and when
So
you
yeah, yeah. So the safe question there, the safe response, not the question, but the response is it depends on the data. Do you have data that map what is available to what you want the AI to find? Right. In the case of archaeology, do you what is available? Pictures of the artifact. What you are trying to find? What are you trying to find? The age. So do you have data where both of these simultaneously already exist in large volumes? This is the standard response if somebody asks, can you use AI to do X?
got
The
it.
standard response is, do you have the data to do X? For the AI to learn how to do X. Remember, AI is learning correlations. It's learning to find these correlations. I'll give you another example. Um, so we were in and we were in a meeting with people at the Indian Institute of Public Health, and they said, we want to improve uh, malnutrition indicators in a certain state. They said the problem is that um, even if you give people nutritious food, and even if they're hungry, they won't eat it if they don't like it. This is a very common problem, apparently. So they want to make food that is palatable. So the question that they asked is, uh, can you use AI to design recipes that people will like to eat by district? So different districts, people have different food preferences. So can you use AI to just do this? You know that using the same ingredients, have a new recipe that will be more palatable to people of district A versus district B. Now, what would be your response to such a question? Well, I'll turn this back to you.
May I?
Anybody?
Taste
Yes,
is
yes.
a very subjective entity, and as of today, we don't capture the units of taste in any flavor. Quantifying taste is difficult, and that primarily doesn't get captured as a data variable.
Hmm.
So
Yeah,
yeah,
no, correct. So this is definitely a valid response. So the response will be, do you have data quantifying taste, right? And map to food items, right? Like if you have food item X or a combination of food items and map to a certain measure of taste. Very difficult data to get. Typically, the counterparty is going to say, no, we don't have that kind of data.
but what if the
And
counterparty agrees to do a survey on a qualitative scale of 1 to 10 rating? Alpan, will that
yeah,
be
then,
decent
yeah, so
data?
if counterparty agrees, then you say, okay, are you going to do a survey where you're only going to map single ingredients to the 1 to 10 taste rating scale? Are you going to map a combination of ingredients? Do you want the AI to predict the taste of a certain combination of ingredients or single ingredients? So you get deeper into the problem,
Right.
right? So then they need data on a combination of ingredients if you want the AI to do this,
Understood.
right?
Alphonse, would it be fair to say that both those types uh, of problems involve pattern discovery, but one involves discovery of correlations that humans cannot discern, and the other
Yes.
correlations that humans can?
Yes, that's what. Yeah, so that's what I was trying to say. That automation involves pattern discovery, but it's patterns that humans already know. Whereas pattern discovery is not necessarily an automation task. I mean, it's not something that you want to do at high frequency or repeatedly or anything like that. Typically,
Right.
it's you want the primary reason for doing it is because humans can't do it.
Okay.
So there are some AI problems that are a combination of these two tasks. For example, our Anthro project, right? Uh, Humans can roughly tell weight from sight from just looking at the baby, right? What are we doing in our Anthro project? We're taking a video of a baby in a rural setting, and the AI is inferring the weight. Our aim is to get to a point where the AI can infer the weight to a very high degree of accuracy, with errors, say 100 to 200 grams, that range of error. Now, a human can probably look at a baby and say, okay, this baby looks well fed, this baby looks normal, this baby looks abnormal, this baby looks underweight. So a human can probably very approximately look at the baby and tell uh, very approximately what the weight is. But it can't, the humans can't do this to high accuracy. In order to do this to high accuracy, the AI must discover subtle correlations, which humans can't. Right? So that's a combination where you have part of the task can be done by a human and you're automating that part of the task. But then there's in order to get to a certain level of accuracy, a human can't do it unaided, right? Similarly, in some radiological applications, superhuman accuracy of AI has been reported. AI is used in many risk prediction problems that humans can't do alone without AI, and so on. Right? Although, again, there is an automation component. Humans can probably do it approximately, but not as well as the AI can. Okay. Any further questions on this before I go on? Okay. So then the next thing I want to talk about is this concept of baseline models. And it's very important in all our work across all our projects to understand what baseline models are. Because many people mean different things when we speak of baseline models. So just want to be clear what we mean when we talk about baseline models. So first, it's clear that developing an AI model is a very resource-hungry process, and all of you who worked with us for some time know this, right? We need a lot of data. There always complaints that data is not enough. The AI team always seems to say, no, 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 this is not good enough. We need more data. We need more data. And the reason they're saying is because they want to improve their algorithm. What does it mean to improve their algorithm? They really want to need more data in order to discover more of these correlations, right? So it's a very resource hungry process. You need data, you need skilled people, uh, very high cost of computing to train these AI algorithms, and of course, it's a while to do it, right? So we should all know this and internalize this, right? That this is a resource hungry process. So we have to be careful before starting work on an AI problem. Um, so one thing I like to say, in fact, because it is so resource hungry, and also for other reasons that we'll get to, AI modeling is really a work of last resort. It's not the first thing you should do. You shouldn't try to solve a problem as an AI problem as sort of the first thing to try. It really should be the last thing to try when nothing else works, right? So it's not a work of first resort. We only apply AI to a problem if it's really worth it. And one of the things that we are trying to address through this whole, emphasis on problem definition and so on, is to ask whether it's really worth using AI for a certain problem, right? Will other methods work equally well or better, and so on, right? And we need to continuously ask this question. So even while we are developing a model, we may change our assumptions, right? And even after deployment, just before deployment, even after deployment, we really need to continuously assess if developing an AI model is worth it. Now, the question is, how do we know whether the model is whether it's worth developing an AI model? The way you know it is typically you compare the performance of an AI model to a much simpler automated way of doing things, right? What is, the AI is trying to estimate something or predict something. So you ask, well, is there a simpler way of estimating this or predicting it? And this simpler method of doing it is called a baseline model. So these simpler models are called baseline models. the assumption here is a baseline model is something that is simple, easy to train, doesn't require too much data, doesn't take a lot of time. Right? Very important. I know a lot of you come from the public health area, where baseline is used in the context of longitudinal studies. That you have a baseline phenomenon, and then something happened, and then you sort of look at the same phenomenon after a certain time, right? So this is not baseline in that sense. A baseline model simply means a very simple model that you can compare the AI model to, right? And that comparison is something we'll talk about later. So just as an example, suppose we have a cuff-based AI screening test for TB, right? A baseline model could be a simple rule that screens for TB using various simple characteristics, right? Like age, gender, duration of cuff, weight, and height, right? We've talked about this type of baseline model earlier as well, except that I didn't call it a baseline model. Right? So you could have a simple rule that says, well, if your age is greater than 40, if you're male, if you've been coughing for 6 months in a row, if you're obese, and if you're, say, if you have a certain height, then then you're most likely TB positive, and you have to go in for further testing. This type of model is a baseline model. Right? This is not the only type of baseline model, but it is a baseline model. Right? And in this case, you're applying a rule. Right? You're saying if age greater than something, if gender is male, etc., etc. It's a simple rule that you can describe as a set of logical statements. This is called a rule-based baseline model. Okay. Baseline model doesn't have to be rule-based. Yes.
Alpan, I have a curious question.
Yeah.
You mentioned that AI algorithms look for invisible patterns to the human eye, which are not already established. And,
Yeah,
and
it
then
can. Yes.
once the models are out, it does have a set of most predictive covariates, etc. And if I construct a revised model with the new covariates popping out from the model,
Yeah.
will it be called cheating, or will the
No.
AI model still outperform the new rule-based model based on the new indicators added?
No, nothing is cheating. I mean, there's no cheating in this. So yes, you can use the AI model to discover rules. In fact, it's a very good question, Jacob. In fact, that's also a hot topic of research. So there is this whole quest to make AI models easier to understand or to improve their interpretability. And one area of research is exactly what you said. Use an AI model to find important features that correlate with the outcome, right? And then ask, can you build a rule-based model just using these features that performs nearly as well as the AI model? Usually they don't outperform the original AI model, but you can, in many situations, and there's a lot of work being done to characterize what situations, but in many situations, it performs nearly as well as the AI model. And then you really don't need the AI model at all. The AI model was only used to find the rule.
Okay. So,
So
Alpan, I
there's
asked
this
this
active
question.
area of research of finding rule-based models using AI, but I didn't want to get into that here.
Okay.
I mean, it gets complicated, but yeah, tell me. Yeah.
There was a slight relevance, Dr. Alpan. Like earlier, when compared to our LFU solution with rule-based model 1, 2, and 3, there is clearly an outperforming, and you can see the visible contrast
Yeah.
and the
Yeah,
value addition model.
Yeah, yeah.
The moment
Yeah.
I construct a rule-based number 4, ML team is working on that. What if that area under the curve is
Similar.
approaching each other? Yeah.
Yeah, then we should use the rule-based model. We shouldn't use the AI. See, it's not worth it. Exactly the same criterion. Why do you want to use a very complicated AI model? And if the AI helps you to discover a rule-based model, nothing wrong with it. Throw away the AI model and use the rule-based model eventually. A simple model is always better if it works equally well.
Okay.
Because
Thanks.
it's easy to interpret, it's easy to explain. You don't need to actually even deploy it. Often a simple rule-based model, you just need to go and tell, like suppose you have a rule-based model using age, gender, cough duration, weight, and height for TB. There is nothing to deploy there. All you have to do is go and tell the health worker on the ground that give him a piece of paper, give her a piece of paper, say these are the rules. If age is greater than 40, gender is male, cuff duration is 6 months, you do this, you do an intervention. That's it. Nothing to deploy, right?
Understood, Alpan. Yeah,
Whereas
yeah.
if you have a complicated AI model, you actually need to deploy it in software.
Okay. Okay. So, Alpan, one more question. Like often I have trouble in explaining it with clarity.
Yeah.
The AI model uses complex stats, maths, as well as computing to give some output. Will the baseline models also use all of them, or are they based on simple regression?
It depends. It depends. Again, it's not. There's no standard answer for this. That's what I was going to come to. So the example I gave here is what I've called a rule-based baseline model. So it's a simple rule, right? It's not complicated. But there are other kinds of baseline models. So there are various types. There's one is a random model. That's also very simple. The random baseline model simply says, for example, again in this TB screening, taking the TB screening example, you just randomly say the person is TB or not. Let's say prevalence of TB, suppose it were 0.1% in the population, right? And you're doing screening of the population. So 1 in 1,000 is expected to have TB. So just randomly 999 times you say don't have TB, and once you say you have TB, repeat the process. This is a random model, right? You're not doing anything. You're just randomly saying with the same prevalence as the TB in the population. So often when you don't have any other baseline model to compare the AI to, you compare it to this stupid random model, because there's no other point of comparison. Okay. So random baseline model is a model in which the outcome is a random prediction. Rule based, as I just talked about, it's a simple model that is a set of rules developed by domain experts in the field, but also it can be developed by an AI, right? That is sort of current topic of research. Then you have an AI based baseline model where you have a much simpler model. It's still an AI model, but it's much simpler. And you use that as a basis to compare the more complex model. So for example, this is something that Makarand and his team have been doing in the Anthro project. So in the Anthro project, we take a video of the baby, right? And from the video, we try to estimate the weight. Now, instead, if you just took a single picture of the baby, right, not a video, and then try to estimate the weight, your video method, since it's more complicated, it better be worth it, right? Because the ASHA worker has to go through this entire contortion of her hands in order to take a video. It's complicated. If a single picture could do as well as the video, then why use a video? So the natural baseline model to compare there is, what is the result I get if I just take a simple single picture rather than a video? And the video-based models got to be worth it. It should be significantly better than taking a single picture if we are to pursue that line of development.
Alpan,
Yes.
when you are saying a simple AI model,
Yeah.
you are referring to the type of data that is
Simple can mean many things. Yes, that's a good question.
Or is it a quantity of data?
It's both. So simple could either mean that the data that needs to be collected in order to train the model is simple. So then this is the picture versus video thing. Picture data is easier to collect than video data, right? It could mean that the model has fewer of these parameters. Remember, I told you that the model has all these parameters and it could have millions of these parameters. The model could have fewer parameters. That also makes it simple. So for example, a straight line going through data points is a simple model. It just has 2 parameters. Okay. So it could mean either of those things, or it could be simply something that's very easy to train. You could train it very fast, or it could be something that consumes much less data. So it could be one of many things. Usually, it's the job of the AI/ML expert to decide, of course, in consultation with domain experts, what is the correct point of comparison. If I'm building an AI model, what should I compare it to? It's a joint decision actually between domain experts, that means program, as well as AI. So it's a case by case. decision.
Got it.
Any other questions?
Alban, I was just thinking, is there an example for the
Hmm.
PEST project? What would
Ah.
be a baseline model over there? Because over there it's a simple counting.
Yes, yes.
Yeah.
So let's see. What would be a good baseline model there is to simply, uh, yeah. So one example again. This has to be vetted with experts. Say you've been setting traps in a particular location for a long time, and you know that in the past you see roughly on the average 5 insects on the trap at that location at that point. Then that is your baseline. You could simply say that, I just take my average from the past. I don't actually need to count the number of insects on a trap. I know what I've been seeing there in the past.
Hmm.
And I use that as my estimation for the number of insects on a trap. Use the average. This
Right.
would be
So
a
with,
baseline model.
so over
And,
there you're kind of
and your AI better do better than that, because otherwise there's no point in taking a picture even. Right?
correct. You're estimating the effort that, you have
Yeah.
to go into the field every day and then,
Yeah.
Okay, understood.
Yeah, exactly. Yes.
Alpan, I just wanted to check with you. Can three-dimensional site problems be solved by two-dimensional photographs?
Qualify your questions. What do you mean?
Example, I'm
Like
interested in the depth of a
Huh.
particular thing,
Huh.
right? Maybe depth of water.
Yeah.
Maybe I took a photograph that captures only the two-dimensional length and breadth of it.
Yeah.
Right?
Again, yeah. So again, this
similar
is
in anthropometry also.
Yeah.
We are taking a video. Does video equate to capturing 3D units or?
no. Video is monocular. It doesn't have 3D vision. But you're potentially capturing the same object from different angles. So you could do triangulation using the video, right?
Okay.
If you're moving the camera, you can triangulate and estimate depth to an object. So you can potentially do that. In our uh, okay, good. I'm getting all these complex questions.
Like how do you
So
get
in
the
our
mass?
in our
My
particular
question was volume into density. So precisely, like how do you get the volume without the 3 dimensions?
Yeah. So you get it through pattern recognition. Right? So that's a simple answer. So in fact, there is work nowadays where just using a single, what is called as a monocular image, meaning an image that is 2D, a single picture, estimating depth from a single picture just by looking at the picture itself and the background, and looking at the. So if the AI has been told that if you have a person standing in the picture like this, and you have a background of houses or lakes or rivers or trees or whatever that have a certain size, which the AI estimates by looking at the picture, then the depth is X, right? So it's been given, say, millions and millions of training examples where it's learned to correlate certain things in an image, certain parts of an image, or certain visual aspects of an image with depth, which this is not an automation task. A human can't do this. This is pattern discovery.
Understood, Alpan. The
And
reason
this
why I
is
was
an
asking
area of research.
right, the
Now,
reason why I was asking that question is because of our induration problem, which is a 3-dimensional thing.
I
And
know.
put
Yeah.
data is the 2D data.
Yeah, but it's not accurate enough at this point. I mean,
Exploring.
it's a very cutting edge research area, this monocular depth estimation.
Great, Alpan. Thanks.
But it falls in that pattern discovery bucket.
Alpan, I have one question.
Yeah.
It could be little silly.
No,
But
no.
how do we arrive at a baseline model, like a simple baseline
Yeah.
model? Do we start with a complex model and then try
No.
to make it simpler?
No.
Or we start with
Never.
simple and then
Never. No, you never start with the whole point of building a baseline is, one of the big points is to ask whether you should even start doing AI,
Mhm.
right? That's often a very important consideration.
Mhm.
So it's really depends on the problem. So what is the problem statement? So let's take a very concrete example.
Mhm.
Sorry, who is asking this question?
Shivi. This is Shivi. Yes.
Yes, Shiv. So what is the area you've been working in? Let's take an area that you've been working in.
So I've been working in pest trap-based
Yeah.
pest management,
Yeah.
anthropometry, and cuff for TB. I'm
You're
working
right.
on three. Yeah.
Yeah, you're working on all of these things, right?
Yeah.
So, what would I do? I would start with, let's say, cough for TB is a simpler problem, right?
Yeah.
Where let's say you're faced with the problem which is from cough sound.
Mhm.
How do you detect TB,
Mhm.
right? And I would say the first question I would ask is there a simple way to do this in an automated manner? Remember, it's important that the baseline be automated, right?
Yeah.
Because AI is going to be, when I say automated, I really mean something that uh, can be done automatically without a human applying judgment,
I see. Mhm.
right? So is there a simple way? So you can ask, so you go to the medical experts. Usually deciding on a baseline model, an appropriate baseline model involves consultation with domain experts. So you go to the medical experts and say that, we are trying to develop this complicated AI that will try to diagnose diagnose TB from a cough sound. But why do you need to do that? Right. So you should question, why do you need to, can't just based on how long the patient has been coughing, can't you tell they have TB? And the medical experts will say, well, sometimes you can tell, sometimes you can't tell. Then you look up the literature. Is there a baseline rule that says that? Is there some kind of, what would I call it, a screening protocol that says that, okay, if the patient has been coughing for this long, and if they have these other things, these other characteristics, then they probably have TB and they should take a confirmatory test.
Got
Now that's your baseline.
Mhm.
You don't need to do any AI to come up with this baseline. In the anthro problem is somewhat special because there's really no baseline to measure weight. I mean, no automated baseline. You could go out there in the field with a weighing scale and measure weight. That's a baseline, but that's not really scalable in the sense you can't really, that's not a replacement for the AI directly
Correct.
because you need human intervention to do it. Yes.
Alpan, often in a new partnership or in a collaboration where data is readily available and you're striking a partnership, at that moment, baseline construction is a mandate for making the job of the data scientist more meaningful, or is it something to establish
There's nothing
value?
to do with the data scientist. It's the job for the institute's involvement to be more meaningful. If there's a baseline that works really well, why do you want to do AI? So your first
I'm a
reaction
new
should be,
stakeholder.
huh,
I don't have a baseline, Alpan, but I'm willing to collaborate with you. In such a cases,
no,
we still
no.
work on a
So
baseline.
they may not, so they may not know that the baseline already exists, right?
Right.
This is part of the investigation into whether we want to do a problem, work on a problem in the first place as an AI problem.
Understood.
Yeah, we must investigate what is the current best practice in doing this. Does the practice involve human intervention, manual work, or is it something that I can put in a computer as a set of rules? That's my baseline model. And then I would ask, how accurate is that baseline? If the baseline is very accurate, then you don't need an AI model. But usually a person would come to you, hopefully if the person already has knowledge in the area, they would come to you because they know that the baseline is not very accurate.
Hi.
Yes.
Yeah, Alpan Sanchika here.
Hi, Sanjay.
Yeah, so my question was an extension to the cuff to be problem only that are we, I mean, I don't know if this exists, but are we experimenting like just training over the features and not the
Yeah.
cuffs?
Yes, very good question. We are. And in fact, the inside story on that is currently just the features without the curve is already producing a very good model. So we are
Yeah.
still, we are asking ourselves whether we really need the curve.
Yeah, because the audio
In
was
fact,
just
Vijay can tell you more about it probably.
okay, okay, fine.
But yes, you're absolutely right. So you have to ask that question then.
Yeah, okay. Thank you.
Yeah. Other questions? Okay. Okay, so this sort of brings us to the perhaps the most important aspect of building good AI models, which is data. And there's all kinds of things that happen to data when we, when we develop AI models. And it's, you don't need to, at least this group doesn't need to understand all the nitty-gritties, but you need to understand overall terminology and, approximately, at least at a high level, what is happening. So I'll go back to my how AI works picture that I had earlier. You had seen the left half of this picture, where if you focus on the left half, don't worry about all these green bubbles. This is what you had seen earlier, that you start with features and label. They both feed it into an AI algorithm, which is trained to find correlations between features and label. The output of the training, again, this is recap. The output of the training is what we call an AI model, right? Which is a file that's on a computer. It contains various parameters. The file contains numerical values of various parameters and so on. And it contains some code telling some set of instructions that tell you how to process new data, new features. So the AI model will then act on new features to give you a prediction. Right? And that part is called inference or deployment. When it's integrated into a software system, we call it deployment. Right? So I hope this left half of the process is absolutely clear to everyone. If not, then this is the time to stop me before I go on to the right part.
Alpan, to be clear, hi, Shrikar back.
Yeah.
Alpan,
Hi,
just to be clear, when you say new features, you refer to a new instance of something, but the
yes,
same thing, whatever feature set was used, ABCD, those four
yes.
ABCD must be here also.
Yeah, the same set of features with new numerical values. Yeah, so that's what we mean by a new data point.
So as an example, if we have trained it in, say, Karnataka, UP, and we are starting to do it for the first time in Punjab with people, so the people in Punjab will start being the new features against whom the predictions have to be made. Whether they're good or bad is secondary. That's what it means.
Correct. And again, we've been discussing this cuff thing for a while. So just to follow up on that, you've trained the model on, say, 100,000 people coughing into a phone, and you know their TB status. So that's the label. And then you apply it to yet another person who is not in the training set, but you pick up somebody from a village that you haven't encountered before, and you ask them to cough into the phone, and the AI predicts whether that person has TB. But they still have to cough. It's the same type of feature. They can't dance, and the AI can predict whether they have TB. Okay, because that's not what it's trained to do. Yeah.
Got it. And although the example you used was obviously simple, but I think in real life, sometimes people make the mistake of thinking a slightly different feature can it be included last minute. None of that is possible.
Yeah. There's a question. I think I heard of some. Yes.
Alpan, you made it pretty clear that AI algorithms pick up new patterns. So patterns, I assume it's the correlation between different features. But can AI also
between features and the label?
Yeah, features and label. Can AI also come up with its own, new features which were not explicitly present in the dataset? I'll explain the question. Example, in the dataset that you're having, say, suppose volume and density as two different features. Okay, and the product of volume and density is giving me a totally different feature, which is not explicitly in the dataset. Will AI make use of such things as well?
Yeah. So again, very, very good question. In fact, it was, before, in fact, even today, I think there's great advantage to using AI models to featureize data, right? So for example, again, I'm just to keep things concrete, I'll keep taking the same example again and again. Again, the cuff sound thing, right? I could just take the raw cuff sounds, pass them through a different type of AI model, which will just convert these cough sounds into a set of numbers. That's all. That's all it does. It's not doesn't do anything that's related to TB or anything. Just converts them to a set of numbers for future use. Now, those numbers can be thought of as features describing that person's cough numerically, quantitatively. Yeah, and they can be used later in other models, in other AI models. I mean, it's somewhat complicated. Don't really need to understand how it's done at this point. But yes, the short answer is yes.
That's great, Alpan. Alpan, could you please dissect a bit on the transformation part? What do we actually do in the transformation thing?
Yeah, I'm coming to that. I just wanted to first make sure that everybody understands the left part of this diagram.
Sorry. Yeah, please go ahead.
Yeah. Okay. So then now to get your data to a point where you can think of the data as a set of features which are numerical in nature and a label, often you have to go through a series of steps. So your raw data may typically not be in this features label form. So for example, if you have videos, your raw data is videos. It's not a set of numbers and a label. And there could be a large number, too many videos. Unfortunately, we don't have that problem yet, but you could potentially have this problem where you just have too much data to work with. Right? So there's a series of things that you have to do in order to get your data to a point where it can be ingested into an AI algorithm. And none of you in this audience need to worry about doing this, because this is not your work. Right? This is the work of the AI team. But you need to understand at a high level what are the various steps. Right? So you start with raw data. Often you have to sample this data. Right? You can't work with all of it. Maybe there are problems with some of the data, or there could be many reasons. So there's a sampling step where you only use a subset of this data. Right? Sometimes you don't have to do sampling, you use all of it. Right? Then you have to clean. There could be problems with the data. There could be missing values. It could be noise, and then you have to denoise. You have to impute missing values or think about how to deal with them algorithmically in a certain way. So there's a cleaning step. Right? After you do all that, you often want to transform, not always again, but in many cases you want to transform the data. And I'll show you examples. I'll show you, later in this presentation, either this session or next session, we'll come to that. You need to transform the data in a certain way so that it's palatable to the AI algorithm, that it can be input into an AI algorithm. A very simple example, suppose your input data is a set of colors from an image, right? Just let's say, that you have, red, green, blue, yellow. The AI typically only processes numbers. It's not going to process red, green, blue, yellow. So you have to somehow convert that text into numbers in a meaningful way, not just arbitrarily. You can't say red is 0 and green is 1 and so on, because your results will change if you call green 2, and you don't want that, right? So it has to be done in a meaningful way. So there are various data, and this is just one example of a data transformation. There are many other types of data transformations you may want to do. For example, you may want to add 2 features, subtract them, multiply, all kinds of things, right? Again, this is really the purview of the AI/ML team, but these transformations, and it takes some experience to know what transformations to do, under what circumstances, and so on. Then there is an annotation step. Again, sometimes the raw data is itself given to you in annotated form with labels, right? Sometimes it's not, but if it's not, then you need to generate the labels, right? So, so there's this whole annotation process that typically involves manual work, right? Very, very important aspect of AI, something again that we'll come to later. But this is the typical workflow. You start with raw data, go through a process of sampling, cleaning, transformation, annotation, and this gets you to labels and features, right? I should really say it the other way around, features and labels, which are then input into your AI algorithm. The algorithm is trained to discover these correlations, result is an AI model. AI model is what you use in the field. Yeah, I'll pause here.
I have a question here.
Yeah.
Malay here.
Hi, Mani.
So you have shown the arrows that are moving from transformation to labels and feature, and the same way you have applied the arrow from annotation to only label, but not to the feature. I mean,
Yeah, I mean, annotation typically applies, they're very rare. Again, see, like I said in the beginning, the statements I'm making here are somewhat of a simplification. There are rare exceptions. And there are some cases where your annotation actually generates new features, but they're very, very rare cases. So you don't need to worry about that right now. Typically, the typical cases where an annotation, human annotation generates a label. Whereas a transformation can be applied both to features and labels.
Alpan, so essentially annotation which you ascribe a label. So if we were to look at any case where you assess a person to either have a disease or not have a disease,
Yes.
and that you just come out independently often. You may not necessarily have any.
Yeah, you
view
may not
of
have
the
an
features
annotation.
also. You may even
Yeah,
not
yeah.
look at the view of the features. You don't care.
Yeah,
You're going to
yeah.
just
That,
independently
that's
evaluate
why,
the guy and say, is it okay or not?
correct, correct. So that's why you can stop at the transformation step and directly go to features and labels. Your raw data itself might contain the label, or you may get the label from somewhere else.
Right. And there are yet others, like if you're doing a pest count on a piece of paper, where it's just a count. And therefore,
Yeah.
you will probably be looking at the features of all the images on something in order to find. You cannot come to the annotation without looking at the features. You can have both.
Correct.
In one
Correct.
where you actually see all these features and then say,
Correct.
hey, there are 5 pests. And another saying, boss, you've got a disease. I don't care what your features say, but you've got this
Yes.
disease.
Yes, and they are often these two, these two different aspects of annotation are often associated with automation versus pattern discovery. So, automation tasks that humans can do, typically, you may have to look at the data to label it. Whereas the pattern discovery task, the features are actually, in a sense, independent of the label because the humans have not learned to associate them.
And in a sense, in a crude sense, the latter, where pattern discovery takes place, appears to be far more mystical and valuable than just automation.
Yes, it's also more dangerous, by the way. I mean, because there are lots of pitfalls, and that's where all the issues of bias and all tend to crop up a lot. Bias in AI models and so on.
And typically, all of those over a period of time, if you see a large amount of data and you keep training your models, those challenges also can be addressed.
Yeah.
At least theoretically.
Yeah. Yes.
Alpan, is data mining a summation of all these individual entities, or does it only apply to cleaning or transfer?
Yeah, data mining is sort of a loose term. Some people include AI in data mining. Again, there are a lot of these loose terms floating about. People use them in different contexts. Data mining. Analytics typically doesn't involve AI. It just involves analysis of data and aggregation of data. Data mining is a very loose term. Many of these things are used interchangeably. So it would depend a lot on the context.
I can add to that a little, Alpan, because I belong to the data mining era well before AI came in. And data mining does not use the principles that AI uses. Data mining uses some very basic statistical principles which are nowhere close to the kind of rigor and the type of science that is developed around artificial intelligence. So I can give you an example of data mining. The data mining at Walmart stores that was done back in, I would say, 1998 or 2000 or 2002, when they discovered it and they did some analysis, they found that keeping beer next to diapers just before the checkout counter increases sales of both, because people who buy one buy the other. This could be later. In today's world, it can be solved more elegantly in AI, but this was just large-scale data and some form of correlation, simple correlation, nothing to do like the way we do now. It's a totally simplistic approach. So data mining is like a very poor cousin of AI, I would say. The way, because I've done data mining extensively, ETL and all, extract, transform, and all those things, they have nothing to do with this.
Yeah, currently it's all gotten mixed up. Yeah. Go ahead. Sorry, was there a question?
No, I was just thanking.
Okay. Okay, let me go to the, so we'll go through these various steps. As I mentioned already, this bit of a recap. Sampling is the process of choosing a subset of the data for input into the AI algorithm. There could be various reasons to choose a subset, as I've mentioned. Cleaning is the process of removing, literally removing dirtiness in the data in terms of noise. There could be inconsistent formats, so you want to reformat it into a consistent way so that it's tabular, with a fixed number of rows and columns. Filling in incomplete values or missing values, things like that. Transformation is the process of applying mathematical operations to data. It could be simple mathematical operations like addition, subtraction, multiplication, or it could be far more complex. And the aim is to change the data to a form that is more suitable for input to an AI algorithm. So just as an example, there's a very commonly used AI algorithm. At least, in the days before deep learning, it used to work 99% of the time, which is called logistic regression, which is really a linear method for classifying data points. It's a classification algorithm, and because it's linear, there's a limitation that it can't find nonlinear correlations. And so a common thing to do was to actually use transformations to create nonlinear combinations of your features. So say multiply two features together to create a new feature, raise one to the power of the other, or something like that, right? And we'll get to things like encodings, where you convert non-numerical data to numerical data. That's also transformation. The annotation process is the process of manually assigning a label to the data so that the AI algorithm can learn to map or correlate the data to the label, the features to the label. I know there's a question, just wait 1 second. So this whole process of assigning a label to the data is also called ground truthing the data. So when you hear the term ground truthing, it simply means annotating or labeling the data, right? And often the label is called the ground truth. The reason it's called the ground truth is because a human has done it, or it's known from a scientific basis that this is the label. And so the terms annotation, ground truth, and label are often used interchangeably. Yes, question.
So my question was around transformation. Now,
Yeah.
because you've gotten raw data, now as a human, you have certain perceptions of what might help
Yes,
the AI.
exactly. Yes, yes.
So, and then you're transforming it to add that layer of information and to help
help
it get
the-
better.
Yes.
So, I mean, could that possibly also cause bias because you're putting in your interpretation of it?
Yeah. So the bias in AI is an amplification of human bias, always, right? So this is where you have to be very careful. And this is a research topic. There are ways of reducing bias, mitigating bias, but the most important thing in this whole bias issue is actually knowing that there is bias. See, that's the first step. And the only way you know there is bias is to evaluate the AI correctly. And you can never get around that. Right? You can apply complicated methods, but usually if you evaluate it correctly, you can diagnose the problem. So for example, if you know that my algorithm, say my AI algorithm has an accuracy of 90%. Is overall, I haven't told you what accuracy is, so don't worry about it right now. Just think of it in loose terms as accuracy of 90%. then you find that it's actually 99% accurate on males, but only 60% accurate on females. How will you know that? If you actually test it separately on males and females, right? So you have to create the right evaluation cohorts. So the whole point of detecting bias is very important. You have to first evaluate the algorithm correctly so that you know where the bias is. Once you know where the bias is, it's much easier to solve for it.
Okay,
This is
and then
somewhat long-winded answer to your question. But yes, you're absolutely right that if you introduce bias through any means, it could be either through the proportion of labels in a certain category versus another category. It could be due to where you've collected the data from. If you collected all your data from Andaman and Nicobar and you expect to apply the algorithm to West Bengal, it will be biases. There could be countless reasons. There could be bias introduced by, like you rightly pointed out, by the transformation process where you, as a human, you applied certain rules to the data because you think that will help the AI, but it doesn't always help the AI. It may help in 90% of the situations, 10% of the situations, it may actually make the performance worse. And that introduces bias.
and just to follow up, yeah. And how do you decide? I mean, of course, I know that this is more in the ML space, and we probably never have to enter this space as a designer or as other team member. But how do you decide what's a good transformation versus, or is it just experimentation?
It's just experiment. So, okay. So there's a history to this a little bit. In today's deep learning era, see, one of the most attractive things about deep learning was that you don't need to decide that the deep learning method or the neural network would decide all these transformations for you. It was an automated way of discovering transformations, right? And that's the common understanding currently as well. Before the days of deep learning, they actually, companies like Facebook and Google would employ people just to find these transformations. And they were, in fact, they were also called feature engineers. That role actually existed for a few years in between. And all they would do all day long was to find good transformations of the data for AI to ingest. That's not considered like a separate role anymore, and primarily because of the deep learning revolution. But you still have to, you still have to think about the data and think about the best way to process it. You can't just leave it all to the algorithm.
Yeah. And just last question on this. Like, I know that typically most teams are involved in like trying to understand exactly what annotations are going in, right? Like what's happening to the data. How aware do you think the rest of the team members need to be about what transformations have been done to the data?
Not much.
Okay.
Because I mean, you do need to be aware of how well the algorithm works on various cohorts of the data. I mean, that's the way to judge the model from where you stand. You don't care what's happening inside, but as long as it works well on all the cohorts I'm interested in, and it doesn't fail in some areas, it's fine. The transformations don't matter.
Got it. Thanks. Yeah.
And Alpan, is it correct as a general statement to say that when human beings do feature engineering and do transformations, then there is a certain sense of intuition and explainability in the model that gets built in because the human being is thinking about it in a certain way.
True. That's the positive side of it.
Yes. On the other hand, in a deep learning,
Ayushi was talking about the negative side of it.
Right.
Yes.
So on a deep learning model, the impact of eliminating bias could also mean a very reduced understanding of why it works, a very difficult way to discover why it works.
Absolutely.
So
Absolutely. That's the trade-off. That's the trade-off. Yes.
I have a follow-up question on this. This is Shivi Alpan.
Hi, Shiv. Yeah.
Yeah. So on the bias thing, since we are discussing this, so you mentioned the main thing in this entire process is to identify if there is a bias, right?
Yes.
But could this also be used to identify the the strength of that AI model. So for
Yes.
example, generally what we do, we infect the model with some known biases and then test the model. Does this also work this way?
You could do that.
Was I
You could do that. I mean, for certain evaluations, but in general, it's true that the same procedure you use to detect bias is the procedure you use to tell how good the model is. In fact, the two are very interlinked, right?
Yeah.
Overall, you evaluate the accuracy of a model, and that tells you how good the model is. But then, if you have differential accuracy for different groups of people, if the accuracy is very different, even if it's high, that tells you there is a bias. That's the very definition of bias. Yeah.
Okay.
And Alban, a related question. I don't know the subject well, so I'm asking: does the term adversarial training have any correlation to any of what we're discussing?
Yes. So you could. Yes, it does. So,
what does it even mean?
So can you fool the AI? So you can. The question is, can you have adversarial attacks that fool the AI? So can you show the AI examples? And so let's say you built a face recognition system, right? It could be a very simple face recognition system. The complex ones may tell you, the name of the person, but let's say we just tell you if there is a face in the image, or a human face, and nothing else. Very simple face recognition system. It works beautifully. You've tested it on all kinds of data. You've gone into the real world, and you've taken pictures of people's faces. You've taken pictures of animals. You've taken pictures of things, and the AI beautifully tells you every time there's a person's face, it says yes, there's a face. Every time there's an animal, it says no, there's no face. Every time there's a thing, it says no, there's no face. So very high accuracy. You've tested it robustly, beautifully. Works beautifully. Suddenly, you give it an example of a face picture, and it says there's no face. And then you start scratching your head and wondering what went wrong. Right? It was working beautifully all this time. What happened? And it looks very similar. If you actually visually look at the picture, it looks very similar to all the pictures you've seen before. But it's not. So it's not in subtle ways. So suppose, so this is an example of an adversarial attack on the AI. So suppose this face picture that you have has been doctored in software where a few pixels in the AI, in the image have been changed in such a way that when the AI algorithm or the neural network looks at it, it sees something very different. It doesn't, it clearly doesn't see what the human eye sees, but it sees something very different. And this is known as an adversarial attack. There are algorithms that will actually produce such adversarial images within the training data, thus preventing adversarial attacks. But these kinds of things can happen to fool the AI. Right? But you would have to consciously create this type of data in order to fool the AI. It's not natural data. Yes.
Alpan, extending to that question, example, imagine my models are trained on JPEG data, and suddenly on some particular format of an image data, and I happen to change the file format of the input data.
If you just change the file format, the algorithm will just fail. It won't predict anything. It will just fail. It will report an error because it's expecting a certain format. This is an image in the same format that it's expecting with all the pixel values and so on, but it's just that you've changed some pixels in such a way that it's not discernible to a human eye, but it's discernible to the AI, and it completely throws it off, and it gives the wrong prediction.
Quick private question to Alban. Is this the same root cause as to why synthetic data is not a good idea?
It's similar, okay. Yes. Synthetic data, sometimes doesn't help because it has artifacts. Yes. Yes, go ahead.
Akash.
Yeah, So I had like a question around like feasibility, like whether we can use an AI at a certain place or not. So I need
Yeah.
some time to like explain like what I want to really ask. So
Yeah, yeah.
yeah. So can we say that like an AI solution where the feedback is not easy to gather? Like by feedback, I mean like at the when you're doing inference, for
Hmm.
every inference that you have done, you
Hmm.
don't get labels in the future necessarily. Does
Right.
it mean that it's a bad place to apply AI?
Not necessarily. It's a it's a it's a cause for caution. It's not necessarily a bad thing.
So
But what I would say is, and I'll give you a specific example actually. Um, um, let's see. But you should be able to evaluate in some way, is what I'm saying, on a continuous basis. So you may not have the ability to evaluate every single inference, but you should either have the ability to evaluate a sample of inferences um, in the future on a continuous basis, or you should have an independent set that is dynamic, that keeps changing, on which you can evaluate the AI. I mean, basically, you need a way of convincing yourself that your AI is still working and it's working at desired accuracy. That is super important. You can do that on a small sample. You can do that in different ways. You don't have to evaluate every inference. So you don't need a label on every inference, but you do need a label on a subset of the inferences,
all right.
right?
So
Um, so let me, I'm trying to think of a suitable example. Um, uh, let's see. So, I used to work at LinkedIn, and one of the features in LinkedIn is to be able to message somebody like an email, right, on LinkedIn. Like there's a chat like interface. Now, suppose uh, you were to, uh, let's say you're on LinkedIn, I'm on LinkedIn. Suppose I were to send you a message that's inappropriate.
all right.
Okay. Um, I complain to LinkedIn, you complain to LinkedIn saying that, look, why are you allowing people to send me inappropriate messages? It's your platform. This is a professional network. You should not send me inappropriate. Nobody should be sending me inappropriate messages. LinkedIn should take care of it. And LinkedIn says messaging is private. We don't want to look at what other people are sending you. And you say, I don't care. You still need to solve my problem. So an AI model, I can't get into details of how these models are built because that's something I can't disclose, but you need a way to be able to build these models and evaluate them while still preserving privacy constraints, for example. So that it gets into that area. At the end of the day, LinkedIn built a model for this and evaluated it on a continuous basis without ever looking at anybody's messages.
Okay. Okay. This seems a little
Okay. Yeah.
complex.
So it is. Yeah. So I mean, I can't talk about the algorithm, but you do need a way of continuous evaluation of at least a sample of the data. I mean, one way that's commonly known that I can talk about is because every company uses it is just to have your own employees send messages to each other and include inappropriate messages and then train on that data. But then evaluation gets difficult. But there are ways around that as well.
Okay. So the abstract picture that I sort of wanted to paint here was
Yes.
like from my personal observation, like the AI solutions which do well are generally the ones in which the feedback is very cheap. So let's just give an example. Let's say
Feedback is very what? Sorry.
feedback is cheap to collect, or feedback doesn't irritate the user. So like a simple example will be like, let's say it's a fraud detection this thing, whether transaction is fraud or not. Let's say even by mistake AI says that a particular transaction is fraud and it's actually not fraud. So it will just send me a simple message like, I think there's something fishy going on. Is it really?
Yeah.
And I just say yes. It doesn't irritate me, and the feedback is also collected. Right.
Yeah. No, but there the feedback is not complete, right? I mean, by flagging certain messages as fraud, it is also flagging other messages as non-fraud. How do you get feedback on the non-fraud?
So, like sort of like user response can be taken as a proxy, like for
Yes, yes. So you need to think of complicated mechanisms. Exactly. So,
and similarly, like just to like go to another answer, let's a word this thing. Like I'm typing something and I want to break next word, like some sort of autocomplete feature.
yeah,
So
yeah.
if I use the autocomplete suggestion, it means AI performed well. If I don't use it, that means AI performed bad.
Correct, correct. But these are all proxy signals, and you have to take that into account and all that.
Yes. So, including this thing, proxy signals, there might be like some solutions even in which, like, if you have to give the feedback, it makes the AI like less like I don't want to quote like a particular solution, but let's say, for example, take Anthro for a solution, right?
Yes, yes.
So there, the feedback would be if the Asha worker at the end is carrying both the like this thing also,
Digital,
like also,
digital.
and
Yes.
this thing also, and this
Yes.
is sort of an overwork. Like to give a feedback, I have to do extra work, and which is
Yes.
irritating. So
Yes. So when you have to do extra work, then you limit. You don't take feedback from everybody. You do intelligent sampling, right? So you say, I still need to continue evaluating my algorithm. It's deployed in say 100,000 Asha workers, 1 lakh Asha workers across India. I'm just like picking a number, and in order to evaluate it, I'll have a special cohort of 100 Asha workers who will take both, and we will pay them for it. This is one example, right? Just for evaluation. And we'll do this every 6 months. And we'll make sure these people are distributed throughout the country so that we get signals from everywhere. So then you use sampling.
Alpert, there are 2-3 questions. I'll just come to it.
Yeah.
I'll just add one
Yeah.
point.
Yeah.
Akash, your point is important, but there is a counterpoint to it, which is that in areas where these measurement feedback is either expensive or difficult, maybe the value of AI will also correspondingly be very high. So the difficulty of getting a feedback in order to ascertain the accuracy of the AI cannot be, it is one factor, but may not be the only one, because in instances where this is simple examples, there are fatality-based examples also. So you have it employed in complex situations, and it is in those very complex situations that the power of the tool, if appropriately managed, into Alpan's point, statistically validly tested, so that it outperforms any form of human endeavor that can be done in that space. So that is the way you may reach, even though it is very complex and costly, the counterpoint is it is actually a very valuable AI solution. Just putting it differently, imagine that you can just take a 10-second video of a baby and get them within, making up something, within 50 to 100 grams, say within 50 grams. The value of that is pan-humanity. You don't need to worry after that. You'll need to do a lot of training.
Shekhar, but to Akash's point, it is only valuable if it is accurate.
Yes.
So you do have to evaluate. Yeah, but you have to evaluate if it's accurate with time.
Correct. You have to, and that is the statistical sampling that you're talking about.
Yeah.
Sanchika had a question. Sanchika said, would LFU be an appropriate example to this? This being the matter you were just discussing, Alpan.
I don't
LFU, no, the outcomes are not private usually because all of this data is in Nikshay. I don't know if that's what you meant or.
No, actually, so what my question was that, as Akash said, you don't get immediate feedback, right, in LFU?
You don't get immediate, you get eventual feedback in LFU.
Yeah,
so you won't know for a while. Yeah.
Right. So, like, basically, accuracy wouldn't be exactly the metric for continuous evaluation in this case.
No, it's still the metric. It's still the metric. But see, let's say you deploy the AI model today and you start getting your first feedback 6 months from now because the outcome is only known 6 months from now. After that, you get it on a continuous basis, right? It's just the first time you have to wait 6 months. Because then after 6 months, as patients have come in 6 months earlier, you've applied the model has been in deployment, you will continuously get outcomes.
So, like, basically, you will get the feedback in batches.
No, that is up
No,
to how
no.
you want to design it. No such
Continuously. If patients see, if patients are streaming in every day, then any patient that comes in today, the model makes a prediction on that patient. We know the result 6 months from now, right? So we have to wait 6 months the first time after the model is deployed. At 6 months and 1 day, you're getting feedback on patients who are going to come tomorrow, right? 6 months and 2 days, day after tomorrow. So then you continuously, like every day, you will get outcomes, right? And you can evaluate the. You understand what I'm saying? So you're still comparing predictions from 6 months ago to outcomes today, but you only have to wait once from the model deployment time to 6 months till you get the first outcome. After that, you don't have to wait. After that, you can still evaluate every day.
Alpan, the reason this gets a little confusing for most of us is for that patient, you're having to wait 6 months. Is how it
For each patient, you have to wait 6 months. But to evaluate the model, statistically, on average, you're then not waiting.
Okay, so as in every time like there is a result, the metrics are recalculated all the time. Okay.
Exactly.
Yes.
The metrics are all
Yes.
aggregated over patients. Yes.
Yes. Don't look at it as that patient. Look at it as information that you're getting about patient.
Yeah.
Actually, it's 6 months old. But today you're getting information for the model. The model only looks at post 6 months because that's how it's trained. Forget about the time element at all completely. Because that confuses us a lot.
Okay, understood. Thank you.
Shri asks a question, can we call insufficient or less data as bias in AI model?
It can be. So there's a statistical concept in that. It's called MAR, or missing at random, versus missing not at random. So if it's missing not at random, it can be called biased. And what I mean is this. So if your incomplete data is, I mean, in other words, if you're bad to everybody, the analogy is this: like if you have a dictator who is bad to everybody, equally bad to everybody, then that person is not biased. He's just bad, right? So it's similar with incomplete data. If all your rows are equally incomplete, or if the incompleteness is distributed uniformly, then you're not biased. There is no bias. It's only if only some of the rows are incomplete and some are complete, then there could be bias.
Thanks, Arpan. Very good example. Thank you so much. Yeah.
Arun had a question.
Yes, sir.
Yeah, Mike, I'm not sure if this is the right time to ask the question, but I mean, it involves like measuring the success of an AI solution and also keeping in
Yeah,
mind
I'm
what you
glad there are
discussed
all these
earlier in
questions
terms
on
of,
measurement and
bias
so on,
and like
because
humans
that's
being
important.
involved.
Yeah, go ahead. Yeah.
So just considering like a scenario where, for example, let's say like Netflix, when you go to Netflix, they have all these thumbnails of the movies and shows they have, and when you hover on the thumbnail, it shows you a quick preview of what the scenes from the movie, let's say.
Yeah.
So I mean, there was a rumor like a few years ago that, for example, Netflix was showing different previews to different people. So, for example, let's say an African American person went on Netflix, and when they hovered on the thumbnails, the previews would show like scenes with more people of African American descent, even if that preview may not have something directly to do with the film. But I mean, so it sounds pretty bad, but assuming the situation where Netflix actually found that it was more effective in terms of getting people to watch those movies, right? So whereas, like, I mean, considering the success in terms of like getting more people to click on it, it worked. But was it the right thing to do, and how is that evaluated? And how is that,
so
like, how is the check?
see, this has to do. See, this directly has to do with the ethics of the outcome.
Yeah.
If you work on outcomes that have questionable ethics and you try to predict those outcomes through AI, you'll run into issues like this. See here, what is the ethics of the outcome? The outcome is to try and get people to see movies, right? Or to see ads. It's the same with ads. Sorry to say, I used to work on ads for, sort of optimizing online advertising using AI, and very similar issues there. So so the ethics of the outcome itself is questionable there. In the work that we are doing, the aim is not to get people to do something that has borderline questionable ethics. If that is the aim in some of our projects, if that turns out to be the aim, then we will encounter exactly these kinds of issues. But certainly that is not the intent.
Yeah, but I'm also wondering in terms of how these ethics can be enforced within the context of like an AI solution. And how important is like human intervention basically in terms of
no, so this has to do a lot with the. I mean, this is a very important issue. There's no easy way to see. It depends. The AI only cares about the metric it has to optimize, right?
Yeah.
In this case, the metric for Netflix, it was trying to optimize views. It had a model sort of that predicted that this person would like to see. Actually, the model probably didn't even predict whether the person would like to see African Americans. They probably predicted that there is a certain set of features in videos that will lead this person to view the video.
To click on it, yeah.
Right? To click on it and maybe view it. Right? And it was just trying to optimize that metric. Now, if instead the metric was something different, which said, try to increase the number of views while at the same time making previews across people, or try to increase the number of clicks while at the same time making previews across people as homogeneous as possible, as similar as possible. I mean, mathematically you can design metrics like that, put them into the AI, and then that is what the AI will do. But who chooses the metric to optimize within the AI? That's the human, right? That's the AI specialist. And the AI specialist in a company like Netflix will be told by the product manager that this is what we want to optimize. So he's following what the product manager is saying. The product manager is going to follow, leadership, because leadership says that if you try to optimize a different metric, then our revenue goes down. So it really boils down to what metric you choose. AI is not that intelligent, right? It's pretty dumb. It's just optimizing. It's finding these correlations depending on what you want to find correlations between, right? And what the constraints are.
Yeah.
So you need to specify the constraints mathematically.
Got it. Thank you so much.
Sure.
And JK had a question which is posted in use cases with a yes or no with respect to event prediction. Alpan, using the same data, can AI help timing of event prediction? Maybe as a secondary.
Yeah, I mean, see, this is a generic question.
He's given an example. He's saying, example, mortality prediction, survival analysis. Now, I don't understand that.
Correct. So you want to predict life. You want to predict lifetime, right? How many years?
When that adverse event is probable likely to happen.
Yeah, so I'm not going to answer this question. I'm going to ask it to you, right? Since you are in program. Now imagine that I am somebody from the NTP and I'm coming to you and I'm asking you this question. Can AI predict this? What will be your response? Given what we've done so
far. We have descriptive statistics on the patterns of the relative leakage of patients for these adverse outcomes spread. So maybe we can try out.
Keep it simple. Keep it simple. No, don't start about trying out. See, trying out is a different. First, you need to have. Remember, if anybody asks you, can you do X with AI? The first question, the first response has to be, show me the data. What is the data you have? Because the AI will simply learn what is in the data.
Right. Good question.
Right?
So we do have the data for the time interval since the onset of say like treatment initiation. I can compute that.
Is it accurate? Is it accurate?
Yeah, well, that needs ground truth study again with a verified valid outcome.
So what is your answer then? You answered your own question.
Right. So I need to do a ground truth study, not only with respect to the event, but also with respect to the exact timing of the event. Got it.
Correct. Exactly. So you answered the question.
Yeah.
Done.
Thanks so much.
And so this goes back to the same things Alpan says, which is the AI requires features and labels. And so if you don't have labels, so at an abstract level, what you asked, JK, may have been requiring the AI to predict aspects for which there were no labels available. And you yourself discovered that the ground truth study will get you new labels for the new problem, and therefore it can be solved.
Then it's just a question of how much. And there you can say, I'm going to go back to the AI expert and say, and get back to you on how much we will need.
And I think this is a very important point. Let's everybody make sure we understand. Solving problem X and solving problem X prime, however close it is to X, as long as its fundamental label is different, simply put, just keep it very simple, it cannot be done. Unless you get X prime's complete data, that is a new problem, however close it is to it, uska bhi ground truth leke aao, phir solve hoga.
Yeah, I learned that during the previous session, Shekhar. This was only for exploring new use case.
Yeah. Anywhere you need the two always in pair. The two, and we'll end in about exactly 2 minutes, I promise. No more questions you can ask next time, but right now I'll take the two. One, Akash has raised his hand, so Akash, go ahead. And Sachika has one question.
All right. So my question is, like, based on things that you learned in these sessions, like importance of feedback loop, importance of having good data sets, importance of having like a good baseline, can we have like some sort of model to grade an AI problem into easy, like tough or hard, like a different gradation, so that within the institute we know like maybe we'll want to like have some sort of risk optimization, right? We want to solve like 2 ambitious problems, 4 easy problems, and like 3 this thing. Can we create some objective metric to classify AI problems into easy, medium, difficulty, and hard for risk posturing?
We can see, it's not going to be black and white, and that is part of the reason why we go deep into problem definition, right? Oftentimes the devil is in the data, in the details. You know, a problem on the outset looks like it's solvable through AI. Once you start looking at the data, you realize that it's a mess. Sometimes the problem is impact. You know, even if we were to solve the problem, there may be difficulties in adoption, then it may not have much impact, things like that. Right? So we work in a fairly complex space where we have to take into account a lot of things. It's not just solvability of the AI problem that matters. It's solvability of the problem that matters. The problem is then translated to an AI problem. Part of it is translated to an AI problem and solved. But the larger question is, you know, how difficult is the problem to solve?
And Akash, 2 things. As Alpan said, this is not an AI domain question. We have almost a 17 or 19 question impact assessment framework that we will roll out shortly. It's already available, but we need to formalize it and train everybody. And that forms the required answer to your question, the formalism, using which you can assess the readiness of a particular problem to be solved by AI. That's your question. Don't worry about small, easy, because it's a very, very gray scale. So you really need to think through and make a judgment as to whether or not you can solve it. Because if you look at those 17 or 18 parameters, you may get overwhelmed, but it actually is the ground reality and truth about everything. Many of those questions, if it is not asked in the beginning, it will be asked later. Except that later when you ask it, the cost is much higher because you've already invested, $400,000 trying to solve the problem. So we will be discussing that after Alpan finishes. There'll be additional training to get those formalisms in as well. Sanchika had a question. I had a similar question with extension to LFU. Can we predict the time range of a patient getting LFU or going for LFU? Is there data available for this? So I think she's answered the question.
I think that's
she's pondered over it.
That's similar to JK's question. Yeah.
Alpan, because of time, I think we'll have to just call.
I think let's stop here. Yeah.
Again, thank you very much, Alpan. Tremendously useful. I think the whole institute is indeed very grateful because I think if all of us learn this well, and we'll continue building on this, it's an applied expertise. So you shouldn't just hear it and forget about it. You should hear it and apply it, and then you'll learn very quickly.
Yeah, we'll get to that. We'll actually assign some homework and so on. I just have to get to it. separate people into groups and design homeworks. Yeah.
Thanks, everybody. Thanks, Alpan. Take care, guys. Bye.
Bye.
Thank you, Alpan. This was very insightful.
Thank you.
That was Rusha.
Bye. Yes.
Thanks, Utpan. Thank you. Thanks, Shikha.
Welcome. Thanks, Shivi.
Thank you.